All right, so welcome to the best Python lecture that you'll have, at least whenever you watch this. So up to now, we have been doing math with some inputs. And those inputs could be stuff that we've imported from a file and done some math on in a iterative fashion. And we take the data; it's in an array. We use a loop to access different parts of it and do math as appropriate. And then we usually print our output to the user, right? And when we did this with the well log, remember last Monday, that meant that we had about 5,200 something lines of output. It's not very useful, right? It's just a whole bunch of data that's going into this prompt, this 12b, which is called console, where I can't import it into Excel. If I'm doing anything with it, I have to figure out a way to copy paste it out of there. And I have 5,000 something lines. I don't think the console even stores 5,000 lines. So I'll use some data. It's not a very useful way of printing output, I guess what I'm trying to say. Especially if you want to move it somewhere else, incorporate it into another program or something. So today, we talk about writing output in a useful way. So what does that mean? Instead of writing to the console, let's write to a file. And actually, let's split this up into two parts. Part the first, you can ignore that slide for a second. Actually, here I'll just jump back up for a second. Part the first and part the second. So part the first is going to be focusing on how do we write output in a useful way. And what I mean by that is, up to now, we've had to just use the print command and commas and string everything together. Whenever we print something using the print command, we don't have any control as to how many decimals we get out, right? We might want to control that, especially if we only have so many significant figures or something like that, right? So our first step is writing output in a useful fashion, just in terms of our decimal place and notation, scientific or floating point. The next step is, where should we write output to? And how do we do that? As said, the console is probably not the most useful place to dump output to. So where can we put it? And the answer is in another file. So how do we do that? Python can write to text files quite ably and very simply. So let's do that. It's also very easy to read a text file into Excel or something like that. So it's a very portable file. So let's do what we can do. So first things first, getting useful output. So what does that mean? It means controlling where and how values go into format, go into what we print. So up to now, if I wanted to print something, I would do something like this. So say I had a number 141.926. So I have that, and I want to print this is pi. Run that. And there we are, right? Excuse me. And I could add some more stuff on the other end of it. Great. But what would be nice is if I had more control here. This number is just printing as it is. If I did some math with this, so say I did like divide by 2.3, something like that, it automatically prints all 15 decimals. I have no control over what prints here. So here we go, format strings. Format strings are what we use to gain control. So what I can do is I can put in my string, this is pi, but instead of ending the phrase and putting in a comma whenever I want to put in a variable or something like that, what I do is I put in a pair of curly brackets wherever I want to insert a variable. So I'll put one in right there. Now I have to tell the code something to fill that. So curly brackets are part of what's called a format statement. So there's my string, my quotes, dot format, open parenthesis, and then I can put the variable that I want to drop into those curly brackets. If I have more than one variable, so let's have that guy there, I can use the second set of curly brackets to drop that variable in wherever I want. How the format statement works is that the first set of curly brackets corresponds to the first variable in the format statement. So this first guy is going to go here. Second guy is going to go to the second one. If I had three, it would go to the third one. If I had three variables and three curly brackets, third variable would go to the third curly bracket, and so on and so forth. It's very straightforward that way. So if I run this, there you are. Num to print went to the first curly bracket, X went to the second curly bracket. Life's great. Now the question is, can I control this bit? Because I mean, I only have what, 1, 2, 3, 4, 5, 6, 7 decimals precision at best here. So I probably don't want to print more than that. So what I can do here is, if I can bring this PowerPoint back up, so I can add what are called print format specifiers. That's all the stuff inside of the curly bracket here. So what those print format specifiers do is they adjust how this number is displayed. They always start with the colon, and then you have excuse me, 3 arguments that you put in, three options that you put in. First one's the minimum field width. You actually don't need to have this. It's totally optional. You don't need to put it in. Essentially, this is the minimum amount of space that the number will take up. So if I go back into Thani, I say 5 point, let me just say 5.7F right now. Actually, I'll say 10.7F. If I run that, you'll note that, and if I take that out, you'll note that the number physically takes up less space on the line. If I count things out here at 10.7F, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It kind of forced in an extra space there, so it'd be 10 characters. So this number would be 10 characters long, minimum. Once it's gone, it just prints the number. It doesn't pad anything. So it's not use. It doesn't really have a use unless you have certain formatting options that you need to hit. Which would be the case for certain programs that you interact with, or certain certain codes that use, you don't have to worry about minimum field width too often. So I usually don't. What I do care about, however, is the second number. So I can say colon, period, and then the 7 is how many decimal places that I want this thing to have. In this case, I said 7. So 1, 2, 3, 4, 5, 6, 7. All right, if I wanted to, I could change that to 10. Now that number has 10 decimal places. I can change it to 1. There's 1 decimal place. 4. Let's see if it rounds. Yeah, and I rounded it to 4 decimal places. So you can control how many decimal places you get by changing that second number. Do the same thing here. Say colon dot 1, because that's all the decimal places that I got. Put an F in there. 1 decimal place, make it 0 if I want. There you go. All right, so that's that. What's this letter here for? So that letter tells Python what format to print in. F means floating point. So a floating point number, well, it looks just like all these. It's just a decimal value, But say I don't want that. Say I want, say, a scientific notation. I can change that to an E. Now it's in scientific notation. Capital E will just make it scientific notation, but with a capital E instead of a lowercase e. No real difference there. So those are really the 2 options that we'll play around with. There are other ones, like G does something. I think it makes it. I forget what that's called. But I mean, I haven't really had to care about it. Yeah, I was guessing on that one. F and E are pretty much the only ones that you'll care about. So I wouldn't care about the other ones. Yeah. If you want to know them, just look. You can look them up there. But suffice to say, that's how you can format output in a print statement. And this is how I would want you to do it from here on out. Now, so now we know how to get output to print the way that we want, right? I can use my print format specifiers in a format statement. I can get numbers where I want them, when I want them, and how I want them. Very straightforward, very neat. So now I need to get them into a file. So there are 3 elements to this. In order to print to a file, I need to, 1, create the file that I'm writing to, or at least identify it in Python. I need to write to it, and I need to close that file. You, of course, always need to open the file, because if it's not open, you can't write to it. So this must happen usually very early in the script. And just once per file. The write, well, you can write as much as you want to it, really. So this one can do as many times as needed. And you must always close the file. If you do not close the file, bad things will happen. I usually put this right at the end. You also only want to do this after you're done writing. And not just once, but after you've written everything to the file that you want. Okay. So close usually does not go into a loop, because then it would run more than once, right? So I usually put it way down at the end of the code. It's just something you do once you're all done. If you don't do it, the file remains open, and if you try to open it a second time, you can get some kind of weird stuff go on. So those three are pretty much what you need. You open once, you close once, you write as many times as you want. There are a lot of different things you can do with the write command. There's this read and append mode. We're not going to worry too much about those. We're primarily going to look at the write mode. What the open command looks like. Well, let's just pull up Bonnie and get to it. So, all right. So let's say that I'm going to write stuff to a file. Well, you know what? Let's just jump into our old well log script and do some adjustments to it. Pull up. Guy. Oh, don't have it there. Oh, don't have it there either. All right. Let me just get rid of these things from. All right. So here's a well log script. Same one that we did about a week ago. All right, so I want to write, instead of a console, I want to write this data, the depth and porosity data. I want to, let's make sure I'm sharing the right screen. I would like to write this to a file, not to the console. It's a whole lot of data. I need it for another program. I want to write it to a file, not to the console. So first thing I'm going to have to do is, if I'm going to write it to a file, is I need to open a file to write it. So up here, up at the top in my initialization section, these are all the things that I only do once, where I initialize my variables. I'm going to open a file or overwrite an old one of these that I just want something fresh. So if you think about that command, the command is open file name. So quotes. I'll give the name porosity.txt. It is a text file, and I'm opening it in write mode. Note the quotations around the W. So that's my file name. That's the mode that I'm opening it in. Now this, like all things in Python, this becomes what it is. So like this mp.loadText command, that becomes the array. And then I save that array as a variable. So this is a file. I need to save this as a variable. So I'm going to call this guy, I usually just call it file ID, or I abbreviate it to FID. File ID is now my file. So before I start writing porosities to it, I'd like to actually, you know what? Let's just write, and we'll get back to this. Okay, so I have my file. I want to start writing to it. So I'll come down here. Here's my print statement. I'm just going to comment that out right now, and I'm going to replace that with the write command. So the write command, if you look at this, it's dot write. So it means it operates on something else, right? np dot load text. It's load text that comes from numpy, right? The dot right, it applies, it's a method, it's a command that's tied to something else. In this case, it's tied to a file. So you can say file ID dot write. Then I can write what I'm going to do. So I want to put a depth in there. So that's going to be a variable. I'm just copying from the print statement. And then my porosity. Okay. Then I can say dot format depth porosity. Okay, and let's do depth to just 1 decimal place, because that's all the decimal places that our data has. And we'll do porosity to 3 decimal places, because that's usually what's useful. All right. Now we got that. And every time that this code runs, well, every time that it used to run, we would run this print statement, right? Every time it runs now, it'll write to a file. So perfect. That seems like it's all set. Then I'll come out of the loop. Once the loop is done, I'll make sure that the file closes. So let's run that. It'll take a second to load not be up. Oh, I used the wrong variable name. That's 4. All right, that was a heck of a lot faster than waiting for it to print. So if I go over to where this file is saved, this Python script is saved in my downloads folder, and where the file that it writes to is going to be in the same folder that my Python script is. So same way that load text works, meaning load text requires that the file that you're reading from has to be in the same folder as your Python script. Here, the file I'm writing to by default appears in the same folder as my Python script. So I can open this guy up, and gosh, it is going to be a mess. Let me expand this to the side a little bit. What's going on here? I mean, I don't even know what this number is. There's 2 decimals in it. Let's see, this is 195 feet. That's like the one number that looks good in this. Well, hang on, 0.311, 195.5 feet. They're all my depths, but they're concatenated on the back of the what's called 3-digit porosity that I had. And if I, and if I look down at the bottom here, see, I'm scrolling way down in this document, right? If I look way down here, look, I'm still on line 1 on column 36,900. What the heck is going on? This is all one row of data. What the friggin' heck? Moral of the story: Python's doing exactly what I told it to. I told it to write data. I didn't tell it to press enter after each line. So if I want to do that, I have to click into my write statement and put in a \n. There are a lot of different / commands you can give in these format strings, and it tells the code to do some different formatting stuff. \n says press enter, go to a new line. So I'm going to run this again. Note that I've closed my text file before I run my code a second time. Make sure you do that, else you'll be looking at old information. Now that looks good, right? My depths, porosities, life's great. However, it'd be nice to have some, it'd be nice to reformat this a bit. As it is, this file would be really annoying to drag into Excel. All I want in Excel is columns of numbers. I can work with columns and numbers. If there are letters and stuff in there, it's going to make it messy. So I want to take my units and my labels of stuff, put them in as headers, say like 2 header rows, one row that says what each column is, then 1 row that says what the units are. And then I can deal with the rest of it. So I'm going to come up here where I first open my file. I'm going to put in my first header row. So I need to write to the file. So file ID dot write. I'm going to put in say depth and porosity. So I have 1 column that's depth, 1 column that's porosity. Right now they're separated by a space. That's kind of, yeah. Be nicer if I could like define a tab, right? I could just tab between them. Well, turns out there's a format to that. So backslash lowercase t will do that just fine. And if I run that, wait for it to finish here. Okay, there's my 3 green carrots. Open up this guy. There you are. Depth, porosity. There's starting to have a nice little separation between them. Ooh, looks like I forgot to put a new line in. So I'll have to do that. \n. Then I'll do it one more time. Put in my units. So units of depth are feet. Units of porosity are, well, there are none, so it's non-dimensional, and I need a new line. Now that I have those labels and those units in there, I don't have to have them here, so I'll get rid of all those. Put a tab in between those guys. Run it. Wait for it to finish. Open up my text file. There we are. Everything's tabbed, so it's all nice and even. I have 2 nice columns of data that I could open up in Excel. They're labeled. Life's great. All right, so that's that. That's our that's how to write to files. Hope that is useful to you. If it's not, feel free to drop by. Playing with this a little bit more on Monday, and I'll see you then.